Welcome to this training session for the OzSTAR HPC environment at Swinburne. So in this video, we're going to cover an overview of the hardware that's available within the OzSTAR high-performance computing environment, and then discuss differences and similarities between our two current machines, the OzSTAR supercomputer and the new Ngagu Tinderbeek supercomputer. Right at the start, I want to reinforce the documentation that's available. So we've put a lot of effort into producing user documentation, which you can find at supercomputing.swin.edu.au/docs. And everything that's discussed here, plus plenty more, you can find there. So it's available to you at any time by reading the documentation. If after reading that you still have questions, then you can contact our helpful team at hpc-support@swin.edu.au, and that ticketing system is monitored all through the week. And yeah, it's the place to go to if you have any questions about your jobs or anything to do with the system. So if in doubt, please ask. If you do not already have an account, then you can apply for one via the address that I've got there, supercomputing.swin.edu.au/account-management. So yeah, please go there. You can lodge a request for a new account or to join a project, and you can also update your details for your existing account. So those are the three places to go for information that you will need. All right, so currently, we have two supercomputers, OzSTAR, which has been in operation since 2018 and hopefully will continue to operate for many years into the future. And our new machine, Ngagu Tinderbeek, which we finished installing earlier this year. So Ngagu Tinderbeek is a name from the indigenous Woiwurrung language for the area that the Swinburne campus sits upon. It translates as knowledge of the void, which is a beautiful name that's been given to us by the Wurundjeri elders. It encompasses what we all aim to do with the supercomputer through our research, which is to improve our knowledge of the unknown. So these supercomputers sit together within the same environment, but they have different addresses. So to access OzSTAR, it's addressed as ozstar.swin.edu.au. And for the new machine in Ngagu Tinderbeek, it's nt.swin.edu.au. There are two head nodes for each machine. And so these are your access points into the facility. On OzSTAR, they're called Whānāko 1 and Whānāko 2, or you can use the shorthand of F1 or F2. Well, I guess as an aside, the naming convention for OzSTAR head nodes and a lot of the hardware internal to the system is a nod to the revered and late comedian John Clark. I'm not sure if he could ever have been described as cute and cuddly, but certainly the inspiration for the naming of the Ngagu Tinderbeek head nodes is a cute and cuddly indigenous rodent called Tuarana, currently in danger of extinction. So our staff were keen to draw some attention to the plight of the Tuarana, and so that explains the naming of the head nodes there, Tuarana 1 and Tuarana 2, or for shorthand T1 and T2. Okay, so many of you may already be familiar with the OzSTAR hardware, but I'll quickly summarize it here. There's 117 compute nodes in total. 109 of those are what we call our standard compute nodes on OzSTAR. They each contains 36 compute cores, which are Intel Skylake cores, 192 gigabytes of RAM, and 2 NVIDIA GPUs. On 107 of the nodes, those are NVIDIA P100 GPUs, and on 2, they are V100 GPUs. Then there are 8 high memory nodes, which have the same specifications, just more RAM, 384 or 768 gig for data-intensive jobs where you need to load up large data sets. So in total, there's 4,200 or so Intel Skylake cores and 234 NVIDIA GPUs on the OzSTAR system. And the nodes are, well, their names are John 1, 2, 3, etc. for the standard compute nodes, and Brian for the high memory nodes, though you don't necessarily need to know that. For Ngagu Tinderbeek, as I said, it's our new machine, been in operation from March this year onwards. It has 182 compute nodes in total, 150 standard compute nodes, which each have 64 compute cores, AMD Milan, 256 gigabytes of memory, and 2 terabyte local NVMe or SSD flash storage option, which can be utilized for fast I/O within the node. There are 10 high memory nodes that each have a terabyte of RAM and the same specifications otherwise, and 22 data accelerator nodes, which have the 64 cores as well, 256 gig of RAM, and 4 NVIDIA A100 80 gigabyte GPUs. So they're very attractive for machine learning and other GPU enhanced applications. So in total, there's over 11,500 AMD cores and 88 of these NVIDIA A100 GPUs. And the nodes without GPUs are called Dave 1, 2, 3, etc. And the GPU nodes are Gina 1, 2, 3, and so on. So yeah, that's, I guess, a key architecture difference between OzSTAR and Ngagu Tinderbeek is that with OzSTAR, we tried to keep the nodes pretty much the same throughout, and 2 GPUs in all nodes. We moved away from that with Ngagu Tinderbeek, and now the GPUs are concentrated in sort of high density GPU nodes, and we have a large number of CPU only nodes. Okay, so another way of looking at how this all sits within the environment is presented here. So we've got OzSTAR, we've got Ngagu Tinderbeek. We expect to run both in parallel for many years. They are networked together, although internally with the network for OzSTAR, it's 100 gigabits a second network. For Ngagu Tinderbeek, it's faster, it's a 200 gigabit per second network, InfiniBand network. And then they both connect through to the same Lustre file system. And the capacity of that by the end of this year will be up to 16 petabytes. So you can freely move around between the 2 machines and to Lustre and move data around between all of those components. So let's focus now a little bit on what's the same and what's different if you're trying to access the new machine versus what you might already be familiar with on OzSTAR. Firstly, it's the same account system and the same projects. So if you already have an account and you already have a project, there's no need to do anything new or get a new account to access the new machine. It's the one account system and the one project system. It's the same file system as well. So your home directories and your project directories are the same, and they're visible in the same way from both machines. The job scheduler is the same, so it's still Slurm. And you don't necessarily need to do anything different to your batch scripts or your Slurm scripts. I'll say a little bit more about that in a second. And the software system is similar in that it's the same module system, although currently the modules that you'll see on OzSTAR, if you look up the modules there, is a different module list to what you see on Ngagu Tinderbeek, because the operating systems on the 2 machines are different. So we've built separate software stacks for the 2. That will change by the end of September. we'll be upgrading the OzSTAR operating system to match that of Ngagu Tinderbeek. So at that point, we will then merge the software stacks. So if you are in the habit of using OzSTAR, now would be a good time to start testing your code on Ngagu Tinderbeek and make sure that it works there, and sending us any requests or queries if it doesn't. But after September 2023, they will be running the same operating system. Yeah, so I think the key factor is making sure that your jobs end up where you want them to go. And that's as simple as just making sure that you submit the job from the head node of the machine that you want to run on. So if you want to run your job on OzSTAR, you make sure you SSH into OzSTAR and that you're on either the Farnacle 1 or Farnacle 2 head node, and submit your job from there, and it will be launched onto the OzSTAR compute nodes. Similarly, for Ngagu Tinderbeek, make sure you've SSH'd into it and that you're on either the Tuarana 1 or Tuarana 2 head node. Submit your job to Slurm from those head nodes, and then it will run on one of the new compute nodes. And it's as simple as that.